Imagine, just for a second, that you're drifting through the freezing, absolute silent void of deep space. Before you lies the ultimate cosmic trap. We're talking about a region so impossibly dense, so utterly ravenous, that the fundamental laws of physics literally break down at its core. You're perfectly positioned right at the edge of the abyss, looking into a darkness that swallows everything in its path. Okay, let's dive into this. What exactly happens if you cross that line? You might remember the climax of Christopher Nolan's blockbuster film Interstellar. The main character, Cooper, plunges his spacecraft into the supermassive black hole Gargantua. He's falling through complete darkness, surrounded by flashing light, these grain-like particles causing sparks and just terrifying turbulence. Well, in this explainer, we're going to put you right in that spacesuit. But to really understand the sheer existential dread of your descent, we first need to look at the physics that are pulling you in. So, to grasp what's happening to your body, imagine our universe as a space-time fabric, like a giant cosmic mesh. Albert Einstein's 1915 general theory of relativity shows us that heavy objects placed on this mesh bend it, and that's what creates gravity. But in the presence of a black hole, this mesh is warped to a terrifying extreme. That extreme gravity doesn't just pull physical objects either. It fundamentally bends sound, heat, light, and, crazily enough, time itself. And that brings us to the totally mind-bending reality you're approaching right now. Special relativity tells us about kinematic time dilation. Basically, if you travel super fast in a spaceship, time slows down for you relative to Earth. But as you fall toward a black hole, you experience gravitational time dilation. It's exactly like the team landing on that aquaplanet near Gargantua in Interstellar. Remember how 1 hour there equaled 7 years back on Earth? Well, the massive gravitational force of the black hole is already forcing time to drastically slow down for you. Let's move along and see how this builds. How does a trap this powerful even form in the first place? Well, it begins with a star. Stars maintain equilibrium by balancing the outward push of nuclear fusion with the inward pull of gravity. But when a really massive star completely burns up its hydrogen or helium fuel, that outward force just vanishes. The star cools down into a red supergiant, violently bursts as a supernova, and its remaining core just collapses in on itself under its own immense gravity. But hey, not every star becomes a black hole. 1.4 is the magic number here. This is known as the Chandrasekhar limit, formulated by the brilliant astrophysicist Subrahmanyan Chandrasekhar. He essentially proved that a collapsing white dwarf must have a mass greater than 1.4 times our sun to become a black hole. So our sun? It's safely under this limit. But massive stars above it? They collapse into the dark void you are currently hurtling toward. To really put the crushing density you're about to face into perspective, think about this number, 50. If a star the exact mass of our sun did somehow collapse into a black hole, all of that unimaginable cosmic matter would be condensed into a sphere with a diameter of merely 50 kilometers, literally the size of a city. It's a terrifying level of compression, creating a gravitational pull so violent it warps everything around it. All right, part 1, Anatomy of the Abyss. Let's enter the chaos. Your descent is really speeding up now. The silent, freezing blackness of space is giving way to a blinding, roaring phenomenon. You aren't just approaching an empty, dark void anymore. You are entering the chaotic, superheated anatomy of the abyss. Surrounding the darkness is the accretion disk. Because the gravitational pull here is so incredibly extreme, massive amounts of gaseous matter and debris are just dragged in, violently orbiting the center. Just like planets revolve around the sun, this debris spins, but at absolutely unimaginable speeds. The particles rub together, they compress, and they turn into this flowing, fluid-like fire that reaches temperatures of over 1,000,000 degrees Celsius. No way around it, it's intensely hot. Now, what's really interesting here is the truth behind these colors. If you recall Interstellar, or even the famous 2019 Event Horizon Telescope photo, the disk is usually depicted as this glowing orange ring. But actually, that's just an adaptation for human eyes, because the disk primarily emits electromagnetic radiation in the form of X-rays, which are totally invisible to us. If you were truly, physically falling toward it right now, the extreme heat means the realistic color of this raging disk would be closer to a blinding, fluid-like blue. And as you get dangerously close, you'll notice another intense visual reality, Doppler beaming. See, the accretion disk isn't uniformly bright all the way around. Because the matter is spinning at dizzying speeds, the particles rotating towards you appear blindingly bright, while the particles rotating away from you seem significantly dimmer. The physics of light are literally warping right in front of your eyes. And then, the breathtaking cosmic illusion completely takes over. From a side view, the glowing disk appears to fold up and sort of wrap over the top and bottom of the dark sphere. But wait, there's no actual matter hovering over the poles. The black hole's gravity is so profoundly strong that it literally bends the light coming from the back of the disk, forcing it over the top and straight into your eyes. It's like a cosmic funhouse mirror. Okay, moving into part 2. Crossing the threshold. The absolute point of no return. So somehow you've survived the heat and the blinding radiation of the accretion disk. But the true nightmare has just begun. The pace of reality is practically grinding to a halt. You're about to cross the ultimate threshold of the entire universe. Just before the absolute darkness, you hit the photon sphere. At this exact distance, gravity is so meticulously, precisely strong that it captures photons, the fundamental particles of light. It doesn't instantly suck them in, and they can't escape either. Instead, the light is forced to travel in a continuous, infinite circular orbit all around the black hole. And this brilliantly illustrates one of the absolute most bizarre phenomena in all of physics. Think about this. If you're floating in the photon sphere and you look straight ahead, the light bouncing off the back of your spacesuit would be pulled into a perfect orbit around the black hole, traveling full circle until it hits your eyes. So, theoretically, you would literally see the back of your own head. But you don't stay there. You slip past the light, crossing the event horizon. This right here is the boundary of absolute no return. Gravity here is so overwhelming that the escape velocity exceeds the speed of light. And since nothing can travel faster than light, absolutely nothing can escape. Now, Interstellar imagined this magical 5-dimensional tesseract where you could communicate with the past using gravity. The grim scientific reality, however, is far less forgiving. While Stephen Hawking proved these horizons slowly leak Hawking radiation over eons, for you, it's a one-way trip. As you plunge past that event horizon, you meet a violently abrupt end. Astrophysicists actually have a chilling, almost comical term for this process: spaghettification. The difference in gravity between your feet and your head becomes so incredibly extreme that your body is instantly stretched and ripped apart. You would disintegrate in literal milliseconds. So, what happens to the fragmented atoms of your body? Well, they're dragged straight down to the singularity. This is the exact microscopic center of the black hole. Here, that space-time fabric we looked at earlier bends so deeply that the curvature becomes infinite. All our known concepts of physics, mass, and dimension completely break down. They just cease to make sense. Time slows to an absolute crawl. Part 3. Cosmic Social Distancing. Safety in the Galaxy. Okay, let's step back from the edge of the abyss for a second, pull you out of the void, and take a deep breath. Because despite the terrifying physics we just explored, we don't actually need to live in existential panic. A super common misconception is that black holes are like cosmic vacuums, just infinitely sucking up everything until the universe is gone. But that's simply not true. Look at Sagittarius A star, the supermassive black hole right at the center of our very own Milky Way. Millions of stars happily and safely orbit around it, exactly like planets orbit our sun. So the crucial point is, as long as we maintain a safe distance, a sort of cosmic social distancing, if you will, we are perfectly safe. Yet, the mysteries still haunt us. I want to leave you with this final, staggering thought. According to general relativity, gravity dramatically slows down time. If gravity at the singularity becomes infinite, time effectively stops. So if you could somehow survive inside that core and look back out, would you watch the entire future of the universe outside flash by and end in a single instant? It leaves us staring directly into the great unknown, facing the ultimate information paradox. Does everything that makes you disappear forever, or is it encoded somewhere out there in the dark? We simply don't know.